Hi everyone, thank you for joining us today. So today's session we're talking about custom vision, talking about how you can get started with computer vision on Azure, specifically using custom vision. This is a drag and drop interface that you can be able to train and deploy your model and use them in your applications. So today's session is very interesting if you're interested in learning different ways you can use computer vision in your application or how you can just add it without adding a lot of code into your project. Before we start today's session, I want to welcome everyone. Remind us that this is a series, and we've been doing this series for almost 3 weeks now. This is our third week. And before today's session, we did a session last week talking about Azure Bot Service and Azure Language. Today we're talking about custom vision, and next week we'll be talking about open AI and responsible AI. So tune in. Today's speaker will be Katrina, and before we go to the session today, I'll want to remind you of the code of conduct. Always be kind and considerate, and also always be welcoming and respectful on the chat. So can't wait to learn together with you all. So I'll invite Katrina, and she'll tell us more about herself and then continue the session. Welcome, Katrina.
Thank you very much, Bethany. So welcome everyone. It's very nice to meet you, and I'm glad to be here. So thank you, Bethany and team, for the invitation. I'm a technology consulting manager in Accenture currently, and I've been a Microsoft MVP for already 3 years, working heavily in the area of AI and data, but more specifically when it comes to data, talking about data science, about data strategy, and working with a lot of data enthusiasts into finding their paths and finding their areas of interest. Now, I was very glad to be actually participating here and talking with you and showing you how to use computer vision, because this is one of the areas where we can literally show how data and AI actually connect, and that the old theory behind data and all the essence in AI and future of AI can actually bind. So before starting, I've been part of Microsoft. I've been part also of clients and partners to Microsoft. So I've been working throughout my career, working through the different areas and different positions towards AI and Azure. So my experience in Azure is from different perspectives. So I hope I can share some of this with you in today's demonstration. Before I start sharing the actual demo, I wanted to spend a few minutes talking with you about artificial intelligence in general. So, what is that, and why are we talking about computer vision, and why are we talking about custom vision as part of artificial intelligence? Now, because this is hard to be interactive and we're not in person, I would like to ask you all to spend a few seconds thinking and trying to define to yourself what is artificial intelligence. So when we're talking about AI, are we talking about robotics? Are we talking about computer vision? Are we talking about checkmate? What are we talking about? So what is AI? And to do that, I'm going to work with you in separating the world into artificial and intelligence. So if you think of the word artificial, so think of anything that's artificial around you. So think of artificial. What is its definition? So is my pencil artificial? Is my mouse artificial? Yes, they are. You can easily look around and point at something that's artificial. Then think of what is intelligence. So think of what makes an artificial object, and pointing you at artificial object, what connects to your intelligence. And it's very hard to define what's intelligence. And this is where artificial intelligence as a subject really hides its depth. Because artificial intelligence is actually our human intelligence invested in a lot and enough processing power, memory, and speed. So basically investing our intelligence into a machinery, into the cloud, into the technology that can actually help us scale it and help it use it in a more smart ways. Now, how does this connect to computer vision? So if we think of computer vision and what it actually does, we should go back to a topic, which is cognitive services. And I don't know if you've heard of cognitive services or you're going to Google it right now. But this is a subset that we're talking about services in the cloud, services in artificial intelligence that we're using to mimic human behavior. And one of those is computer vision. So basically, we're trying to build algorithms. So we are building algorithms. We are using computer vision algorithms to understand and to recognize different objects or different pictures or different elements in our world. So if you think about it on a very basic level, we could easily do that, right? If I have enough knowledge about all the logos in the world, for example, like Microsoft logo, Apple logo, Coca-Cola, etc., then if you use me and my site, I'll be able to recognize all the logos at all the different locations. Now you can understand that this is hard to do. Like even if I learn by heart all the logos in the world, that will be a second topic. It will be fruits, like all the fruits in the world. Like this is a bit easier than the logos, or all the flags in the world of different countries. Now, this is a classic scenario of intelligence being invested in enough machinery. So now, if you take my knowledge and if I take your knowledge on, for example, country flags, we can be able to expand our algorithm and our intelligence. And then if we place this into a machine or if we place this into the cloud, we'll be able to create an algorithm that's complex enough to understand logos and flags. Now, this would still be limited, wouldn't it? When we're talking about computer vision and when we're talking about the power of the cloud, we need several prerequisites that I'm going to be talking about today and that we're going to use today. The first thing is that we need to have an idea. So what are we actually doing? What are we going to use computer vision for? Are we going to use pictures of logos? Are we going to use pictures of flags? Are we going to use pictures of fruits? What do we want to do? Do we want to recognize food? Do we want to recognize flags? What do we want to do? So this is the first thing. The second thing is we need our tool that would help us scale it. So we'll need access to cloud. And then the third thing is that we need the necessary resources to do that. So we need the idea, we need the cloud, and we need the resources. Now I'm going to share my screen and start now with showing you, just give me a second, with showing you first the tool that we're going to use. So first of all, we're going to use, can you see my screen? I hope you can.
Yeah, we can. Yeah.
Okay, thank you very much. Thank you for confirmation. So first, for today's demonstration and for today's tutorial, we're going to use Custom Vision AI. So this is a tool provided by Microsoft that is actually going to help us create our first model. But to do that, first you need to go to this link, customvision.ai. This will be the one where we'll be training our model, where we'll be testing our accuracy, and we're going to see the results that we're doing. So first, access to Custom Vision AI. You're going to receive a link also in the chat. Then the second thing that we're going to need is an Azure account. So I hope that most of you already have this. And the third thing that we're going to need is a set of different pictures. So what you can do is you can go to some kind of search engine images and just download a set of pictures of something that interests you and that you would like to build the model at. In my case, I've downloaded pictures of strawberries, apples, Microsoft logo, like this one, and apple fruit, and then Apple logo. Okay. So going back to the Azure portal. So if you already have some experience with Azure, you know how to navigate this. But otherwise, what you need to do what you need to do here is really try to search custom vision in the portal and build our resources for training and prediction. So under services, you see custom vision. So after you type it, please select custom vision. Okay, and as you can see, it will be under the category cognitive services, which we've already discussed. In this, you see that there are different services under vision, under language, under speech, open AI. So you can use this as a hub of finding and booking different services as well. Now here you can see that I've already created two of them. So for training and for prediction, we will use both of them in today's demonstration. But what you can do is click here on create. Okay. And when you click create, you have to select the first option, which is to either create only a prediction or only a training part of the resource. In my case, I've created both. You would use your subscription, you would use a resource group, or you're going to create one. And when you do this, you have to type your region, your name. I'm just going to do this now very fast to show you how to do this. Okay, test custom vision. Then we're moving to network. Okay, that we are going to access through internet. Okay, this we're going to leave blank and then review and create. Okay, so in my case, I did not fill all of the information, so it's going to be failed. But for you, you should be able to create this. So we are creating both prediction and training custom vision resource in Azure. We need this so that we can do our model. Okay, so again, you go to portal.azure.com, which is the Azure portal. You type custom vision. And when you get there under cognitive services, you will be able to create this one from here. When it's ready, you should have it like this, visible. Status will be succeeded. So it should not take longer than a minute for creating this one. So this is our first step. This is how we secure our resources for the training. Now, while you do this, I'm going to the page Custom Vision AI. So I hope you already have access to this one. So when you do that, you're going to see this initial page before you sign in. Here you have to sign in, where it's nothing more than the 3 steps that we're going to follow through today. So uploading the images, training your algorithm, and then evaluating. So what did your model create and what did you create exactly out of this algorithm? Okay, you have to sign in with the same username and the same profile as you did in Azure. So going back, when you sign in, what you have here is, if you've already used it, you have several projects. But what we are going to do is we're going to create a new project. So when you're creating a new project, so think of the name. The first one will be, I'll be using Strawberry and Apple project. Okay, you can enter a description for your project, and this is the place where you use the resources that we've created in Azure. So in my case, I'll be using Custom Vision. So I hope you can see yours as well. If you haven't done it, you still have the option to do this here by creating new resource. But it's always good to have this in advance. So if you haven't linked your account, you may not be able to see this one. Then on the second, on the next option, we're going to select the project type that we would like to do. So it will be either classification or it will be object detection. So these 2 projects would vary, and today we're going to do both of them. So first we're going to start with classification. So in classification, we're going to tag different pictures. So we're going to use the whole image and the whole picture to be tagged by the selected by us tag. And what we're going to do is then we're going to proceed with object detection, where we're going to be selecting specific areas out of an image or out of a picture that we're going to tag. Then when we go to classification, we're going to have classification types. So what we're going to do is we're going to select either multi-label or multi-class. So either a single tag per image or multiple tags per image. This would vary, and I'll most probably now select the multi-label, so multiple tags per image. It will be it will be easier to work with this one. Now, when you're selecting those, at first it may seem very random selection, but if you have your idea behind of exactly what do you want to do and what do you want to build as a model, then these options would be easier to answer. And then finally, if you fall into one of the domains, so for example, I would fall into the food domain, but you may be using to work with something in landmarks or retail, or you can just use the general domain. Now, if you want to export your model and publish your model into mobile, so iOS or Android, you should be using the compact modes here. So food compact, for example, I'm going to use food compact. And then you're going to see the export capabilities. So basic platforms like TensorFlow or Vision AI Dev Kit. Sorry. So in our case, let's select this food domain. Now, something that I forgot to mention is that Custom Vision AI, you can only access in Edge or Chrome. So if you do not have access to the platform, please use either Edge or Chrome for that. Okay, so what we're going to do now, is just click Create Project. Okay, risks of the live demo. Let me just refresh the page and create a new project, Custom Vision project. Okay, multi-class. Okay, now it works. When you create your first project, what you have is this page where you basically have to add pictures, and you can see that these are the different criteria that you have to meet. So it has to be GPG, you have to be PNG, BMP format, and up to 6 megabytes per image. So we have several constraints that we have to take a look at. Now here you can see how many iterations, so how many times have you trained the model already, and whether you already have pictures that have been tagged or untagged. In our case, we do not have any pictures at all for now. What we're going to do now is add images. So I'm going to get to my desktop, images, and then I'm going to get to the strawberries pictures. Good. Okay, I'm going to try to load all of them. Okay, upload. Good. And what I have the option now to just add a tag and say, okay, these are strawberry images. So I'm uploading. Okay. Apparently 12 of my images were uploaded successfully and 8 not, because they were not consistent with the requirements for the images. What you can see here now is that it accepted my description that these are strawberries. And now we have tagged images of strawberry, 12 of them. If we go to untagged, it will be 0. And here we can select, okay, strawberries, and we can see every picture that's been tagged as strawberry. Now, if I go and select training of my model, like the big green button on top, and I click quick training, I'll get an error that I cannot train this model, and it will not make sense training it, because what we need to do is we need to have at least 2 tags and 5 images of every tag. Now, 5 images is still too little, but for demonstration purposes, this would be enough. What you would do and what you need to do is really try to think of the picture that you're placing here. So if you really want to get into this image recognition properly, you would need to think of the different angles and the different visuals you could provide of one thing. So for example, the strawberry, and here you can see it could be whitish, green, small, big. It could be cut, or it could be in between some leaves, or it could be more of them on one place. So if you really want to get the right algorithm to recognize your object or your picture, you should be thinking about first the quality of the picture. So if it's a bad quality, and even if it's hard for you to recognize it, then it would be hard also for the algorithm to understand that this is strawberry. Even if you pointed it, then the next picture should be the same, and it will be only recognizing low quality strawberries. But first think of the quality, think then of the quantity. So if we're talking about 5 pictures, if you have, for example, 5 pictures of strawberries, and then you teach the algorithm to recognize apples by providing 500 pictures of apples, then the algorithm will be performing much better at the apples rather than the strawberries, because the data is too low. So Microsoft recommendation is around 50 pictures, but again, if it's 50 pictures of the same profile of the object, this would not be that good. But it's good to provide like a variety of angles, light, and the quality, of course, of the picture. Now, what we're going to do now is I'm going to select more pictures, and I'm going to add images of apples now. So going back to images here, and apple fruit. Okay. Let me select all of those and click upload. Okay. So I can see that I've selected 15 images that I've downloaded, and I'm not going to get and assign any tag. Okay. So here I can see that I have all my images uploaded, but I have one that consists of both strawberries and apples. So what I'm going to do is I'm going to select this picture here and delete it. Okay. Good. Again, I'm on the untagged images. What you can do here is, if you have a set of images that you have not selected, but you're just loading, you can go to Get Suggested Tags and try to find the best image here that you could use and the best tag you could use. What we can do is select all and tag them with the new tag, which will be apple. Now you can see that I have a recommendation to do first strawberry, to use my first tag, or to use negative tag. The negative tag would be very easy to use for me if I'm only trying to do a strawberry algorithm, for example, because if I use the negative tag, it's basically saying this is not strawberry. And in our case, if we want to teach a model, for example, how to recognize strawberries in multiple fruit baskets, or in a supermarket, if you're doing a pricing algorithm and you're using computer vision, so if you want to use your phone to scan and say, okay, this is strawberry, then I would use the negative tag. In our case, I would use apple. I would just create a new one and save and close it. What I have here is 2 tags. Now, if I click on apple, I will only see the apples. If I click on strawberry, I will only see the strawberry. Okay, so this is how you create tagged images. Good. Now, what we're going to do is we're going to train our algorithm, and I'm going to use quick training because we are in a live demonstration. So while the training is doing, we're during our first iteration. What you can see here is that this is the first time I'm training this model. If I decide to add more images because I didn't like the performance of the algorithm, then I'm going to have second and third and fourth iteration, and this could go on and on training the algorithm. Now, what we're doing here with pictures and with this custom vision project that we're building is really laying in the area and in the basics of data science. So going back to training models, going back to data science and data modeling, when we're trying to predict, because here we're trying to predict whether an object or whether a picture is actually the object that we want it to be, we have to build confidence in a model. So we have to really train a model to be really understanding what's the object in front of it. So we have to provide the right quality, we have to provide trustworthy sources, and we have to provide enough quantity so that the model actually knows what it is looking for. You can imagine that if you train a model for strawberries and apples, and then you're looking for apple, for example, but it could mix up also logo, it could mix up the food if you're giving a data, so multiple images on one picture or multiple objects on one picture with mixing tags. So we have to be really clear. What is the picture that we're providing? What is the thing that we're looking for? When and where and how are we going to use it? Now, when you create such a model, I told you already about one application at the supermarket. For example, if you want to weigh your strawberries or your apples that you've selected, and then attach a price and just do your application. But image recognition and computer vision is often used for product quality as well. So imagine we're talking one production line and, for example, light bulbs. And you have pictures of broken light bulbs and of good quality light bulbs. You can imagine that the tags would be good quality, low quality, medium quality, dirty, broken, like you can have multiple tags. Now, when you use this and you teach your algorithm to understand what is a good quality bulb and what is a bad quality bulb. And here is the intelligence element, right? Because how would you understand if one is burned down, one is broken? So it's very easy to say if one bulb is broken or it's good. But then if it's small or if it is some category and there are some visual characteristic for that. We'll need to train this algorithm at the tags that we need to do and to have. And then based on that, when you export your algorithm, when you, for example, export it to your phone, so use it on your iOS or on your Android, and then go to the production line. So you're the inspecting manager and you go there and you just go with your phone through those. You can easily spot which are the proper one, which are the good one. Now, if you're talking about optimizing this algorithm, we can just implement this in the production line, and this could give us a rate of how many good quality bulbs were produced, and then share these metrics to the company. We can do a lot out of very simple scenarios, and the basic way of working is this one. The thing is that the most important thing is your understanding of the topic, of the business topic, and the question and the hypothesis that you're trying to solve. So you can use Custom Vision as a tool, and it's amazing too, that you can use to train yourself, for example, with strawberries and apples. But then think of the bigger picture and think of what you want to really try in your life. If you gather on pizza parties, like use this algorithm to show off and, for example, track if it's a pepperoni or something that's a bit more complex. Okay, so our first iteration is done. So is my whole story of application of the algorithms and the models. So what you can see here is that I'm playing with the probability threshold, which I was training the algorithm at 50-50, which is not 50%, which is not that good, but let's increase it. What you can see here at the first iteration is that I used my food domain. This is my first iteration, and I have three indicators of how good my model was. Okay, so first is the precision of the model. So this is answering to me. And again, I have 12 images and 11 images, which is very low quantity of pictures that I've inputted here. But this is telling me to what extent my model is likely to be right. And here I have 100%. Because it's not that hard of a model. But so for example, if we had 100 pictures of strawberries, 100 of them would be strawberry. And then the recall is actually then out of the tags that we have predicted, how many of them would have been correct. So this is the precision and the recall, and the probability threshold is something that's showing us to what extent our model is correct, like what is our probability threshold that we're looking for. You can imagine that 50% is a chance. So 50% is, you could easily guess, like you do not need a model to do that. So 50% is absolutely low. And in the different categories, you can see different probability thresholds to be used. For example, in weather predictions, it will be much lower than, for example, for food that we need to do. Okay, so this is performance, and we can publish, or we can go to a quick test, so that we see what's happening with our model. So right next to train, we can go to quick test. Now, in the quick test, you could be absolutely sure, okay, I've trained my algorithm to recognize what is a strawberry and what is an apple. So what I'm going to do is I already have a picture that is strawberry and apple, and I'm going to use this one and try to understand what is it. Okay. In our case, this is recognizing apple 94% and strawberry only 6.6%. So now you can imagine that this is giving, because we have 3 strawberries and we have 1 apple, this is not exactly the way we would like to understand it. But what we can do is we can still train our model to recognize strawberries or apples if it was the wrong way or the way around. And we can do several iterations. So typically after the 4th iteration, I got it to 50-50 and with more pictures and more knowledge. Now I'm going to use another picture just to show you. Okay, this one here. Okay, see, what we have here is now we have much more artificial apple and a bigger strawberry, but we can see that here the increased rate is 66%, lower rate for apple, but increased rate for strawberry 35%. Good. So what this quick test is giving us is that our model is not good enough. And if we go back to our pictures, for example, for strawberries, what I can see here is that most of my strawberries are like a big quantity, so I have multiple of them. Most of them are cut. So I might be thinking also of another set of images that I would like to have. Okay. So under training images, we'll have the tagged images for apples and for strawberries. We'll have the performance here, and we'll have our predictions. It is interesting because here we can toggle around the different iterations and the different models that we've built. And we can see the different probabilities that we got. So for example, if I really think if this one is an apple, I'm going to just select apple tag or add a tag, and then this, okay, I'm not saving it. This is going to be added to my training images, and my second iteration is going to consider my predictions as well. Thus, we'll be optimizing the model. Okay, good. So once we have this, we can publish again. we publish the model, and then we can use it. Okay. So this is the first model that I wanted to show. Now, when we go back to Custom Vision and we go to a second project, we're going to proceed with object detection. So now we were doing classification. So we're classifying images into strawberries and apples. Now we're going to do object detection, which is a bit more interactive with the picture, and within one picture you can be tagging multiple things. Now I'm going to
to interrupt you before we go to object detection, there are two questions in the chat. They are somehow similar.
Okay.
The first one is, how many trainings are recommended?
Of the model. Yeah. Well,
Yeah.
this is interesting because you're going to observe your performance, and you're going to observe to what extent. Right now we got numbers that were too good to be true, with too little data and too little iterations. So you're going to track your performance, your precision, and when you do the tests, you're going to see to what extent and how exactly did your algorithm recognize the picture that you show. So you have to test it. You have to really see at the end, and based on your idea, what you've provided, is it good enough, and is it responding to those precision metrics?
Yeah. The second question is similar in terms of like how many iterations are good to have a somehow perfect model without overfitting.
Mm-hmm. Yeah. Well, exactly. So yesterday I got it by the fourth time, but again, it depends on the quality of your pictures. It depends if you're giving enough pictures. So sometimes it could be earlier, it could be later. It depends really on the pictures, on the angle that you're providing. It's a lot of factors that you have to consider, and really what do you want to see? Because if it is a single strawberry, then I'll have to be very specific and find 50 pictures of the perfect strawberry from all the angles, or I can use one from Jeff and just separate it and use it like this. So it really depends on your quality.
Okay, thank you. I'll leave you to go to object detection. So if anyone has a question, they can just post it on the chat and we'll reply to it.
Thank you very much. Thank you very much.
Yeah.
Good. Going to the object detection, which is the second topic. So let's put it as logo detection. Okay, again, we're using our same resource. We're going into object detection. Here you can see on all these information all the information points, object detection finds the location of content within an image. So you have this guide also here as well, so that it's as easy as possible. I'm going to get to logo, but I can use general as well. Let's use logo. Okay, and we're creating our first project. Now I'm going to add images of, I'll be using Apple and Microsoft. So let's use Microsoft. I hope that those pictures would work. I haven't checked them for their characteristics. Okay, all of them work. Good. And they're all untagged. So what we're going to do now, I'm selecting this image, this first image, and you can see that here I have an option to have regions showed. So already recognizing like the different parts of the image, what could be a taggable part. And I'm going to select this one. I'm going to use this as Microsoft logo, and I'm going to do this tag Microsoft. Okay. As you can imagine here, I can also type Microsoft, or if it's something else, I can add something else, but I'm not going to tag it. So only this part. Then we're proceeding to the next picture. Okay, this is a very clear logo. You can adjust your screen like this. Okay. Again, Microsoft. Okay, it's good that we have only 7 pictures. Okay, here as well, Microsoft. Okay, Microsoft. Good. I really prefer the regions shown option. Okay, you can see that all pictures disappeared from here. This we already know. These are under tagged. So if I click, I'll see Microsoft. Now, if you go directly adding images here, all of these will disappear. So go to untagged to add your second set of pictures, which will be Apple. Okay. So what I've done here with Apple is I've selected pictures that are very different from each other, just to test how would those be recognized. So, okay, let us create a new tag. See, so here you can see a different angle, different color, different shyness. So to different extent, the logo would be represented in a different way. In one picture, it will be black. In another one, it will be twisted to the left or to the right, or it will be shiny, or it will be 3D. And this picture here shows really a representation of all the different Apple. I'm not going to tag this one. IDs, logos. Okay. So as soon as we do that, we're going to try out how good our algorithm is. So you can understand that these are only few pictures, so only 7 pictures of Apple, and all 7 of them are very different. So it is not very feasible to understand and learn the model to them. So we have to have a set of images that will be representing this one and this one and this one, so that the model actually trains. Okay. So this is our database. So we're going to work with those pictures, and we are going to train our model. Okay, we need at least 15 images for every tag. So now we have to find more images for Apple and for Microsoft. So I have not downloaded a lot of them. So I would need to add some more images. But while we're doing this, I'm going to be talking now. Just give me a second. Images. Okay, images. I'm just going to download a few more. Okay, Apple logo. So we need 8 more pictures to train our model. So when you think of these models and recognizing logos and object detection, I would like to think to ask you to think of all the TV shows that you've watched and commercials. If you've seen a bottle of water that's been very like a specific brand, or if you've seen them drinking Coca-Cola for several seconds. Or if you are a football player, or you like watching football matches, in those cases, when we watch some kind of a sports show, we can see all the sponsors there being constantly advertised, and we can see those changing all the time. So in those cases, when we observe this, we basically know that each ad and each of these ad is actually being paid a lot of money. So one of them costs a lot of money. And when we would like to actually calculate if this is visible, how many times have we seen the logo, this is one of the cases where we can be talking about logo recognition and using logo recognition. Or, for example, in a video or a movie, or on the TV screen while we're watching TV series, how many times did we see this? And this is how a pricing model could be structured for a certain company. Okay, so I think I've got enough for Apple. I'm going to go to Microsoft now and really try downloading more pictures for this one. So you'd like to be a bit more picky than I am. I'm just trying to get several of them. What we can do now is not to waste more time. I'm going to add some more images now for Apple. Okay. And the others will be negative. Okay. Select all. Good. And again, we're going to do the same thing. I'm afraid we do not go out of time, but we still have 15 minutes. Good. Apple. Good. Now, when we go, we'll have 12 of Apple and 7 of Microsoft. So we still need a few more to go. So I'm just going to get all the Microsoft one as negative. Okay. We're just going to spend a few more minutes into selecting those. In the meantime, are there any questions for the object detection?
So far, there are none.
Okay.
Yes, so if you have any question around object detection, you can just paste them on the chat and we'll be here to reply. Yeah.
Okay. I hope you can still do this while you are watching this live video, or afterwards go back and do it. It is very useful to train it first with things that are familiar to you, because when you do that, you can actually understand and see how many times, for example, did a specific picture appear, or an object that you are already knowing is there. Okay, one is duplicate. Good. Okay, I hope I have them now. Yeah. This is okay. Okay, so we have 15 of it. Now let me try to do something else. Desktop images, strawberries. Okay. For time's sake, let's do this. Okay, good. Okay, now we should have 3 more. 1, 2, 3. Okay, good. Good. So let's train the algorithm now. And we're going to, again, do a quick training. And what we're going to see afterwards is we're going to use one common page with the logos and see to what extent did it recognize the Apple and the Microsoft. Now, this is a classic representation of bad quality data. So what we're currently seeing is very different pictures of, like, this is a variety of pictures of the Apple logo, which is typically good, but we do not have them in enough quantity so that they could actually teach the algorithm that we have the time element, so they've been changing in time. We have the marketing element, so they are different colors based on the different campaigns that they've been exposed to, and we have them on different backgrounds, which is good. Like different background is one of the characteristics that we'll be looking at. Same is valid for Microsoft plus the strawberry images, which are actually false data. So this is wrong representation of data. This is data that could confuse us. And if we teach the algorithm that a strawberry is Microsoft, then the algorithm would recognize Microsoft as a strawberry. This is the element with intelligence, that if the human intelligence recognizes an object and sees an object in one way, and it is actually something different, then AI could not be understanding it in another way, because this is how we've designed it, and this is the knowledge that we've placed into it. And this is how we actually build, and you would know this, that when we build any algorithm or any project or any product within AI, and we build it ourselves, it will start off with our intelligence and what we build up. What do we connect then as knowledge databases? What do we connect then as additional data or opportunities to collect data? It is interesting how it works, but it is more interesting because of how we've designed it to work. Like, what were the different hypotheses that we set there, and what did we actually want to achieve? So did we want to track how many times our company logo was presented during TV series or during a sports event, and thus say how much we're going to pay? Or do we want to see how many times, for example, to see at how many events have our logo appeared, for example, this year? So it's interesting. It's interesting the cases that you're building, and the way you monetize this and the way you use it in projects. If you think a step beyond the technical, because you can see that we can do multiple iterations, and we can play with the probability threshold, we can play with the overlap threshold, we can play with the precision of our model, we can play with the training images, we can understand our performance in different ways and accept it, even if it's a bit lower. We can predict different things, but if you know it, and you know that you can publish, you can export, and you can take it out to the world. Just think of the scenarios that you could do this, because technology is only powerful when we apply it properly. Otherwise, we discuss it as great technology, but if we do not apply it, if we don't talk about its application, and that's your next session for responsible AI as well. When we do not share our knowledge, and when we do not use this technology in the proper way, nobody could see it for something more than a technology. And it is developing so fast that as of this moment, we can see custom vision portal where we can perform this. Only a few years back, we were doing this on a completely separate way. So technology is evolving to help us apply it better.
Yeah. Thank you for this. There's another question from the chat from Felix, and is asking, I tend to think object detection and classification are a lot alike. So is there any difference between the two?
Sorry, Bethany, is there a difference between what?
Object detection and classification.
Yes, there is. So in classification, we were tagging like the whole image, the whole picture. So let me use one image while this is training to show this. So in this case, we can classify this image as apples, correct?
Apples. Yeah.
Yeah. Oh my goodness, it's a very low quality picture that I've selected, but I can use this one as well here. Okay. Okay, so here we can be talking about one picture that's apples, or one picture that's fruits, or one picture that's colors. So this could be under different classes. So depending on your idea. But when you're doing an object detection, for example, you could be looking for the marble floor that you
With surface, yeah.
yes
Or
the
it will be separating the green and the red apples.
yeah, or you can be using this could be tagged as green, this could be tagged for red, this could be the yellow part. So this could be delicious apples as well. This could be like sour apples as well. So you can just work with you depending on what you want to find in this picture.
Okay, and there's another question before we go to the results. There's
Mhm.
another question on, is there an equivalent for NLP? An equivalent of this for NLP?
Like a portal, I have to check if there is something that's so ready made for NLP, unless Bethany, you know. Uh,
Yeah, I can say technically for Language Studio, the lookalike is the Visual Studio, but
yeah,
it's something that's closely related to this because you can be able to test, but then the problem with Language Studio is it's an already existing model. So if you want to detect handwriting, there's already an existing OCR for that.
yeah,
So for custom, I cannot say for sure. Maybe because most of the things in like language, most of the times it's already there. Like translations, there are already languages uploaded there over thousands of not thousands, but a couple of languages uploaded there. So it's a
yeah,
bit hard to customize. But I can say Language Studio. Check Language Studio in case you need a very customized solution. I think that's something we can dig into and figure out. But I think that's the best equivalent.
yeah. And also, like depending if you would like to understand speech, or if you want to extract sentiment, like there are a lot of like demo environment when you can check this, or where you can upload your video or use the APIs, or just use this one.
Yeah. Okay, you
Uh,
can go to the results. Yeah.
okay, so again, you can see the similar results. We have the precision, we have the for the recall, and now you can see that it is very like much worse for Microsoft than for Apple, and this is only because of the strawberries, of course. Now, if you want to do a quick test with the pictures here, okay, we would like to see what will happen with this one. Okay, okay, good. So what we can see is that Burger King was tagged with Microsoft, so Apple was recognized, and okay. And then for Microsoft, the algorithm got really confused because of what we did with our pictures. This is
Yeah.
only Apple. The good thing is that we have Apple here. So I'm going to test another thing. Just bear with me. We're going to test with the strawberry. Okay, no predictions. At least this is good. Because I was also selecting random pictures. Now here we'll try with a different logo of Apple. Okay, and we can see that Microsoft logo, although we had only few pictures of it,
Yeah.
it's recognized with 65.5% because most of them were focused on exactly this image, and
Yeah.
Apple is not recognized at all. Okay.
I think it also tags Google because of the colors.
It does, and it changes with the threshold value. But yeah, it could be. So this is a classic example of overfitting as well.
Yeah.
But yeah, but be careful with the data quality, and you will not have such mix-ups, because you can see that with the few pictures we still got Microsoft here, but not Apple, because actually we had only few pictures that were this specific black logo of Apple. Okay, I think we're out of time. Thank you very much
Yes.
for your time, and I hope you enjoyed the demonstration.
Yeah, thank you so much. So before we end, there's someone who's asking about does Microsoft provide any predefined model for this? Yeah, for the submodels that are already predefined. For example, there's some popular logos that you can be able to identify, and things like identifying famous buildings, landmarks, identifying if there's people in an image. With that, you don't need to go to Custom Vision Studio. With that, you just use Computer Vision API for that. And then there's someone asking about the cost. So there's always the free tier, and then the standard tier, and then the more premium tiers. So depending on what your usage is, you can define where you want to be. If you're a student, the free tier is normally available to you regardless. So provided you have that subscription, you'll always get the free tier. But
And
thank you so much.
yeah.
Yeah, go ahead.
No, I wanted to say when you're creating your resource in Azure, you're going to see those stars and you're going to see the pricing models as well. So there is in the portal of Azure, you can see the whole graph and you can calculate it on your own. Thank you very much. Thank you, Bethany.
Okay. Yeah, thank you so much. Before we end the session, I'd like to also remind you for our next week's session. We have a session on Tuesday, same time. The session will be interesting because we'll be talking about the Azure AI service. So if you're interested, the Azure OpenAI service, sorry. So if you're interested to understand how you can build things like chat prompts, how the basic building blocks for ChatGPT and so on, you can join the series and learn more about the Azure OpenAI service. So I'll paste the link on the chat so that you can be able to RSVP there, sign in, and you'll get a reminder for that. But thank you so much for joining us today, and I hope you all have a good rest of your day.
Thank you. Have a good day.